It's World War II. The United States are developing their new superweapon for the Allies. It's a huge project and costs the US over $2 billion, which equates to about $35 billion today. It requires the work of over 600,000 people, and it's the first large-scale research conducted on nuclear science. By now, you may have guessed what the superweapon is: the atomic bomb. Perhaps the single most destructive weapon ever created, and one that changed the course of history forever. On July 6, 1945, the atomic bomb Little Boy was dropped on Hiroshima, Japan, killing over 100,000 civilians in the initial blast, with an additional 100,000 casualties and permanent effects for other survivors. But the same technology that allowed for destruction on such a gargantuan scale is being used today to explore new frontiers. That's right. Nuclear science is now being applied in space travel, empowering humanity to reach new heights and gain a better understanding of our universe. For instance, NASA plans to put in a 100-kilowatt reactor on the moon by 2030 in order to support the new Artemis program and its astronauts by powering a lunar base and equipment. Another honorable mention of nuclear science used in space travel was the Cassini probe to Saturn. Cassini was a deep space probe that traveled over 9.8 billion kilometers, powered by radioisotope thermoelectric generators, and kept warm in space and during its descent to Saturn's moon Titan using radioisotope heater units, both powered by plutonium. There was also NASA's Deep Space Atomic Clock, a system which miniaturized modern atomic clocks already used for triangulating the position of bodies in space by calculating the time a signal takes to reach the clock on Earth from the object. This new system allowed for those calculations to be done in real time and on board a ship, and because of its new incredible accuracy, might allow for things such as self-driving spaceships in the future. Moving on to our last, and perhaps the most significant use of nuclear science and modern technology for spaceflight, was the Nerva rocket created by NASA in 1962, which admittedly isn't all that recent, but has led to much new research and development being done today. The Nerva project was a uranium-powered rocket engine designed to propel a spaceship. It was shown to be over 3 times as efficient as traditional rockets, and its development was of a scale so large where many problems had to be solved, like the fact it got so hot that it melted the graphite needed to contain the reaction. But, if used right, could allow humanity to reach new frontiers. These technologies are just the highlights of many in this ever-expanding application of nuclear science. The initial science that was first used for bombs and destruction is now also being used for the betterment of human civilization and humanity's evolution, paving the path for interplanetary travel and deep space explorations. And it was all made possible by those first scientists who split the atom, Otto Hahn and Fritz Strassmann, as well as many who came before and after them, from Marie Curie, who first discovered and coined the term radioactivity, to the scientists of the Manhattan Project, who were the first to find a practical use for such potential energy.